Hey 8th graders, welcome to your third video for chapter 2. In this video what we're going to be doing is we're learning how to write two-step equations. In lesson 2 you learned how to solve two-step equations. You want to get rid of addition or subtraction, then get rid of multiplication or division. And what we're going to learn to do today is we're going to learn how to write two-step equations. So that's what we're going to be practicing in this lesson. And not only are we always going to write them, but we might solve some as well. So Chapter 2, Lesson 3, Write Two-Step Equations. Our objective for today is to write two-step equations that represent situations. So we're going to read a situation, and we're going to write an equation that represents that situation. The standard that we're going to be focused on 8th grade standard, equivalent expression 7, equivalent expression 7a, and 7b. Let's go ahead and start our first example. For our first example, we're going to be solving the problem 8 less than 3 times a number is negative 23. So we're actually going to write down using numbers what we read. Now in this case we're going to have to write the equation of what we're reading. It says 8 less than 3 times a number is negative 23. So we have to figure out what is 8 less than mean. Now a lot of people might think that this means 8 minus 3 times a variable equals negative 23, and that would actually be incorrect. The word less than or the word more than actually happens at the end of a sentence. So I'm actually going to kind of write that over here. Less than or more than happens at the end. And this is kind of a general rule of thumb. Anytime you see the word less than or the word more than, that means it's happening at the end. An example of how this works. If I said, what's 2 less than 5? A lot of you are probably thinking that 2 less than 5 is 3. And that's absolutely correct. But you didn't do 2 minus 5 to get 3. You did 5 minus 2 to get 3. This one is actually the correct statement. If you had 2 less than 5, you're actually taking 2 away from 5. So in this case, when it says 8 less than 3 times a number, you're taking 8 away from 3 times a number. So the first thing that you should have is 3 times a number. And since they didn't tell us the number, this is where a variable would come into play. So I'm going to put 3 next to the variable n. Remember that a number next to a variable means multiplication. 3 times a number. 3 times a number n. And I'm taking 8 less than that. So I'm taking 8 away from that. If I have 8 less than, it's like this. 2 less than 5, I'm taking 2 away from 5. The word less than or more than happens at the end. This has happened at the end of the problem. So 8 less than 3 times a number. 3 times a number minus 8, because we're taking 8 away from it. The word is in mathematics typically means equals. So it equals negative 23. Negative 23 is my answer. So in our first example, if we're told just to write this into an equation, this is all we got to write down. 3 times a number minus 8 equals negative 23. 8 less than 3 times a number, we're taking 8 away from 3 times a number, and that's our answer. So if you guys are looking to copy this down, here it is. That's it for example 1. Let's go ahead and move on to example 2. In example 2, we're going to be translating this sentence into an equation. So that means we're taking words and we're writing numbers for them. It says 3 more than half of a number is 15. Remember that less than or more than really means that that's kind of happening at the end of the problem. One of the things that you can do when solving a problem or when writing an equation is you can kind of write the numbers above them, and then you can rearrange them and put them in the order that they're supposed to go in. So I see 3. I'm going to go ahead and write the number 3. The word more than in mathematics means addition. So I'm going to be adding 3. So I'm going to add 3 more than half of a number. So I need a half. Now, of a number. Half of a number. The word of in mathematics means multiply. So half times a number. The word is in mathematics means equals, and 15 is obviously 15. So what we got is we have a plus 3, half of a number equals 15. Now we're just going to reorder it and make sure it matches what the sentence says. It says 3 more than half of a number. Again, the word more than means it happens at the end. So we're going to take half of a number and we're going to add 3, and that answer is going to equal 15. And this is our answer. We have written this statement as an equation. And that's all we had to do for this example. Let's keep going. Alright, for this problem here, we have 13 is 7 more than 1/5 of a number. So we're going to try to rewrite this as an equation. 13 is. So I'm going to use kind of the method we just did. We're going to write the numbers. 13 is means equals 7 more. So that means we're adding 7. 1/5 of a number. 1/5, the word of means times, and times a number. Now we're just going to rearrange it based on the rules that we were just talking about. It says 13 is 7 more than. So I know that 7 is being added at the end of the problem. So in this case, I have 13 is 1/5 of a number and 7 more than that. Now, since we're actually adding numbers, the order in which you add these doesn't matter, but if you're going to go for accuracy, this is the answer that matches what we're reading. 13 is 7 more than 1/5 of a number. And that's the answer to this problem. Let's keep going. In this question, we're going to be translating 19 is 2 more than 5 times the number into an equation. So, example 4, translate this. I'm going to start by writing the numbers. 19 is 2 more than. That means I'm adding 2. 5 times the number. That means I have 5 times the number. Now, we just reorder based on the words and how they are supposed to go. 19 is 2 more than. Again, the word more than happens at the end. So I would have 5 times the number plus 2. And this would be my answer to example 4. Hopefully you guys are getting this. Fairly simple stuff, I think. And if not, please come see me and I'll work with you on trying to write out the words and to what the numbers mean. And so let's just keep going with some more problems and solving those. In example 5, we're looking at a story problem, and what we're going to do with this story problem is we're going to write down an equation based on what we read, and then we're going to solve the equation to figure out the amount of books or what the original price of a book was per each one. So, example 5 says you buy 3 books. So we're getting 3 books, and they all cost the same amount. So we don't know the price of the books, but we do know they cost the same amount. And you're also going to get a magazine. So you get 3 books and a magazine, all for $55.99. We do know the magazine cost $1.99. Our job is to figure out how much each book costs. So what we're going to do is we're going to set up an equation to figure out our solution. We do know the total. Our total is $55.99. We know we get 3 books, and they each cost the same. And we also know we get a magazine, and the magazine is $1.99. So the stuff I've underlined in the problem is the stuff that we're going to use to write our equation. So we have 3 books that we don't know the cost. So what we're going to do is we're going to say 3b, because that's how many books we got. We got 3 books. Plus, we only got 1 magazine, so there's no point in putting $1.99 a magazine. We could just put plus $1.99. Since they only got 1 magazine, we could take 1 times $1.99 and figure out that they paid $1.99 for the magazines. We also know their total. Their total is $55.99. So now, knowing this bit of information, we can actually work backwards to find our solution. So I got my calculator ready to solve this problem. I'm going to draw a line through my equal sign, and I know I want to get the letter B alone. So I'm going to make my box over here to say kind of what's happening to B. So looking at B side, I see that I'm multiplying by 3, because 3 is multiplying by B, and I'm also adding $1.99. And we learned in 2-step equations, the first thing you want to typically get rid of is adding or subtracting. So I see I'm adding $1.99, and the opposite of adding $1.99 would be subtracting $1.99. So we're going to subtract $1.99 from one side and subtract $1.99 from the other side. $1.99 minus $1.99 cancels out. We still have 3 books is equal to $55.99 minus $1.99 is $54. Now, all we got to do is solve for our books. So, we got to get B by itself. We got rid of the $1.99, so I'm going to go ahead and cross it out. We still have times 3, so the opposite of times 3 is divide by 3. Divide by 3. And books are going to equal. Now I'm going to kind of do this in my head. I can take 5 and divide 3 one time. 5 minus 3 is 2. So I'd have 24 left, and 24 divided by 3 is 8. So the books would cost $18 a piece. I'm going to go ahead and check in my calculator and make sure my math is good. So I'm going to type 54 divided by 3, and 18 is correct. So $18 is the price of the books. Each one would cost $18 if it was $55.99, and you only paid $1.99 for the magazines. Let's do another word problem and see what happens. In example 6, what we're going to do is solve another word problem. It says a personal trainer buys a weight bench for $500, and they buy W weights for $24.99 each. The total cost of the purchase is $849.86. How many weights were purchased? So in this problem, since they say that W represents weights, our variable that we have to use is W. Anytime that you have a variable actually announced in the problem, you have to use that specific variable in your equation. So we know that a personal trainer buys a weight bench for $500. So we know they're going to pay $500. We also know that they're going to add to their cost W weights for $24.99 each. So remember that numbers go in front of variables, so it's $24.99 for each weight, but we don't know how many they're getting. That's what our job is to figure out, how many weights they purchased. So I'm just going to underline the things I've used already. We have W weights, and we have $500 for the bench. And our final thing is we have $849.86 for the cost. So we know that the final total is $849.86. Now we're going to get our variable W by itself to figure out how many weights this person has purchased. So we draw a line through our equal sign. And we want to get the letter W by itself, so we get rid of first what's on the same side as W but doesn't have a W. We're going to get rid of 500. Now, in order to get rid of it, all we have to do is say, do we add 500 or subtract 500? Well, if we add 500, that'd be 1,000. So let's subtract 500. So we subtract 500 on one side, subtract 500 on the other side. 500 minus 500 cancels out, and we still got $24.99 for each weight is equal to 800 minus 500. That's $349.86. Alright, so I'm going to grab my calculator because this is not something that I'll probably do in my head. I know that I want to get W by itself. And if I want to get W by itself, I'm going to have to divide by the number that's with W. So I'm going to divide by $24.99 on one side, divide by $24.99 on the other side. This cancels out, and we get W equals $349.86 divided by $24.99. They got 14 different weights. So I typed in my calculator 349.86 divided by 24.99, and I got 14. That's how many weights they purchased. Let's do one more problem, and you guys are awesome and done for the day. Alright, for our last example, example 7, we're going to be talking about a lunch problem that deals with the situation that maybe some of us have seen before in the past. It says your and your friend's lunch cost $19, so we know our total. Our total is equal to $19. It says your lunch costs $3 more than your friend's. So we know that it's going to cost $3 more than your friend's. How much was your friend's lunch? So right now, we don't even know how much our friend's lunch is, but we do know that our lunch costs $3 more than our friend's. So what we would do is we would say that maybe C is the cost of our friend's lunch. So this is where we're setting a variable equal to the idea. Since they didn't give me a variable anywhere, I'm going to use C for the cost of my friend's lunch. And I know that my lunch is $3 more than my friend's. So my lunch would be C plus 3. So what I did was I used the fact that I know my lunch is $3 more than my friend's. And C represents my friend's. So I added $3 to my friend's. So I know that when I put these two together, or I add them together, I'm going to get 19. So C plus 3 will equal 19. And our job is to figure out C, the cost of our friend's lunch. So I'm going to go ahead and erase this now. Hopefully you guys got that down. If you didn't, rewind the video, pause it, and copy that down. How many C's do I have? Well, anytime we have a variable by itself, we can always put 1 beside it. If I have 1 C and I add 1 C, I really have 2 C's. So 2 of my friend's lunches plus $3 is going to equal 19. So if I say that I have 2 of the cost of my friend's lunches and I add $3, that's $19 total. Again, that's because this right here represents my lunch and this right here represents my friend, and if I add them together, I get 19 total. Now we can actually solve this problem. We draw a line through our equal sign, we subtract 3, cancels out. We have 2 C's equal 19 minus 3 is 16. So 2 lunches would equal $16. We divide by 2, and the cost of my friend's lunch is $8. And the cost of my lunch is the same as my friend's plus 3 more. So I would take 8 and add 3, and I would get 11. So my lunch is $11. My friend's lunch is $8. And if I add those two totals up, I should get 19. $8 plus $11 is 19. So I know I got the correct answer, and I know that 11 is 3 more than 8. So this is absolutely the correct answer. That's it for today's lesson. Make sure you like this video. If you haven't yet, subscribe and smash that notification bell so you get notifications anytime I post a video for you. You guys did awesome today, and I will see you in class tomorrow.